Got exam walkthrough series on the work, energy, and power for AS Physics. So I have a question here. It says a crane lifts a load of 3,400 Newton through a distance of 26 meter. The power input to the crane is 5.7 kilowatts. The efficiency is 0.38, and we have to calculate the time taken for the crane to lift the load. So we know power is equals to energy divided by time, and then time will be energy divided by the power output because basically the power output is what is causing the crane to be lifted. We're putting in some input power, but out of that, some of it is lost, and the rest that's left over is going to be used to lift the crane. So in this diagram, we can see that we're inputting some power. Out of that, some is getting lost and the other is remaining. And that remaining power that is there is the reason why the crane is being lifted. And this is 100%. Out of this, 38% is left with us, and the rest, 62% is lost. That's basically what this 0.38 means. If you times it by 100, you get 38%. So basically, I'm going to do power input divided by power output. It's going to be 0.38. Or actually, I kind of flipped the formula. Should be the power output divided by power input. My bad. So you're going to take that, and then you're going to do, and you're going to get, now remember to do times 10 to the raised power of 3 because that's going to be important because it's in kilowatts, and you're going to get 2,166 watts. There's another way to do this as well without the formula. You can say 5.7 times 10 to the power of 3 is 100%, so what's going to be 38%? You cross multiply, and you're going to get 2,166 watts again. Alright, pretty simple. So we get this as the power output. Now for the energy, we're going to have the force times distance is equals to the work done to lift the crane, okay? Well, actually, the work done to lift the crane should be equals to mgh. And we know mg is the weight times h. That's why they've given you the weight of the load. Because the load, when you raise it up, when you lift it up, it's going to gain the gravitational potential energy. So we should actually say GPE. Okay, 1 second. GPE is equals to work done by the crane. And that's why we can say work done is equals to the weight times h. So then you're going to do 3,400 times 26. You're going to get 88,400 joules. You're going to divide both of them, and you're going to get the time value as 40.8 seconds. Now I want to explain this part a bit more because I know it might be a bit confusing. So let me try to explain it. So I've drawn a simple model. Imagine this is the crane and this is the mass. Now the crane is doing work to lift the mass. So the work done by the crane is being converted to the work done by the crane is being converted into the GPE. Does it make sense? When the crane does work, it lifts the mass. So the mass gains what energy? GPE. Why does it gain that GPE? Because that work is being done. So I can say that work done is equals to GPE. That energy of the crane is equals to that energy that the crane gives to the mass is converted to the GPE. Okay, and then where GPE is mgh and mg is just the weight. So you can say E or work done as well, and if it is fine. Okay, so yeah, so that's the answer to this question.